All right, so I think I'm recording. Let's take a look at these homework problems. We are doing operations with radicals and specifically addition and subtraction. So we're going to treat these like terms. Um, we can put a coefficient of 1 here and a coefficient of 1 there, and we can say, well, these two terms are like terms, but this one's different. We have 1 radical 5 plus 1 more radical 5 for 2 radical 5s, but unlike multiplication, I can't put I can't combine the a radical 5 plus a radical 2. So that's my final answer. Over here, same idea. Let's put ones in front of here so we can count how many we have. We have a radical 2 and we have another radical 2 for 2 radical 2's. And this radical 3 is unlike the radical 2, and we can't combine those. Those are unlike terms. So there's our two answers for the first two problems. Let's move on. So what do we have here? We have three terms this time, and we'll put a 1 in front of here. And notice yeah, like I say, that not only do we have three terms, but they're all radical 2, so they're all like terms. So all we have to do is do the operation with the coefficients. -1 minus 3 is a -4, and -4 plus 3 is a -1. And you can put a -1 or you can just put a negative symbol either way, and that's our final answer for number 3. So for number 4, these are all square roots. We have three terms, and they all are radical 3. So these are all like terms. We can combine them together. The -3 and +3, these are going to cancel each other out. They add up to 0. So our final answer is just -2 times radical 3. All right, so this time we have unlike terms, and this time, it was pretty obvious when you had the square root of 2 or 3, that those small prime numbers, that you couldn't simplify the radical. But here we have to question, hey, can we simplify the radical? And remember, since the radical is a cube root, we're not looking for a pair of numbers, we're looking for a group of 3. Well, when we look at 4, it breaks down to 2 times 2, so we don't have a group of 3, so we can't simplify this first radical. But what about 108? 108 is divisible by 3, and then 36 is 6 times 6, and this is 2 times 3, and this is 2 times 3. So I do see that I have one group of 3 factors. So I can take this 108 and write it as 3 raised to the third power times 2 squared. So when I go to take the cube root of this, I can break this apart and take the cube root of each one of these factors. Well, since this exponent divided by that, you have one group of 3, the cube root of 27 is 3. And we can't simplify the cube root of 4. So this first term, we noticed that we couldn't do anything with it. We have 3 the cube root of 4. But we know that we can rewrite the cube root of 108 as 3 times the cube root of 4. Those two terms are equal and opposite, so they cancel each other out, and our final answer is 0. So this original subtraction, that's a very ugly way to get the number 0, but it does simplify to 0. Let's look at the next one. So we have two terms. Each term contains a radical. And when we look at the index, the radicals, these are cube roots. So when we break them down, we're looking for a group of 3. So we've already seen that 4 breaks down to 2 times 2. It doesn't have a group of 3. So this first term, we're going to leave it alone. There's not really anything that we can do with it. But we can come over and break down 32. We know that 32 is 4 times 8. We know that 4 is 2 times 2. And that 8 is 2 times 4. And that 4 is 2 times 2. So we have this 32 and is equal to 5 factors of 2, 2 to the 5th power. Now, we're only wanting to deal with groups of 3, so we can break it apart and say that we'll take 2 to the 3rd power with 2 left over. See, if you wrote out 5 factors of 3, you have one group of 3 with 2 left over. So this first factor is just the number 2, because you have a single, or 2 to the first factor. You have a single group of 2. And the second factor, 2 squared is 4, we can't simplify that. So over here, we're subtracting 2 times the cube root of 4. So we notice that these are like terms. We have 3 of these minus 2 of those for just one of these cube root of 4. And if you want to put a coefficient of 1 there, that's fine. I usually don't. All right, so there's my final answer for number 6. Or number 7. So right now these are unlike terms, but it's possible that we can simplify the 4th root of 32 and the 4th root of 162 and maybe rewrite those in such a way that we very likely will be able to combine them. So we need to break down 32, and 32 we saw in a previous problem that we had 4 times 8, and that this was 2 times 2 and 2 times 4 and 2 times 2. So we've seen that 32 is 2 to the 5th power. And so that 5 is more than 4, so we're definitely going to get one grouping out of it. Oops, why did I change it to the 5th root? The 4th root of 32 is the 4th root of 2 to the 5th power, but I'm going to break that apart. I'm going to have a group of 4, and then I'm going to have one left over. So I know with this group of 4, since it's a 4th root, that I just have a 2 come out. 4 divided by 4 is 1. But I can't simplify the 4th root of 2. All right? So, oh, and don't forget that we have a 3 right here that comes along for the ride. And the 4th root of 32 is 2 times the 4th root of 2. Now, let's break down 162. breaks down to 2 times 81, I believe. 81 breaks down to 9 times 9, and 9 breaks down to 3 times 3. So we have a group of 4 factors right there. All right. So this fourth root of 162, we can break it apart and say, hey, that's the fourth root of this group of 4 factors of 3. And remember, we have this 2 that was by itself, and that there wasn't enough of them to simplify it. So 4 divided by 4 is 1. We have one group of 4 factors, and each fact, it's the number 3. So over here, this is 3 times the fourth root of 2. So here we can multiply 3 times 2 and get 6. And look, we do have like terms. It was too hard to recognize it the way it was originally written, but in simplifying it, we've recognized that, hey, you have 6 of these fourth roots of 2, and you're taking away 3 of these fourth roots of 2. What you'll have left is 3 of these fourth roots of 2. Let's move on. We have 2 terms, and right now the terms are unlike. They're both fourth roots, but we have here this fourth root of 3, but over here we don't have a 3, we've got 243. So we're going to try and break that down. So the 3 is going to come along for the ride, and let's come over here and take 243 and break it down. So I believe that 3 times 81, didn't we just do this one? 9 times 9, 3 times 3. So yeah, right there is a group of 4. So the fourth root of 243 is the fourth root of 3 to the 4th power, with this one factor left over. So we have one group of 3s here. We didn't have enough factors of 3 to simplify to get a second group of 4. So this fourth root of 243, we can replace it with 3 times the fourth root of 3. I'm going to put a 1 here just to visually help me when I go to do the subtraction. 3 times 3 is 9, so I have 9 of these fourth roots, and I'm taking away one of them. So 9 minus 1 is 8, so I have 8 of these fourth roots of 3. And there's our final answer. Let's take a look at these last two. So they've given us more terms, but it's still the same. Ooh, it's still the same idea. How do I do that? Can I undo it? Yeah. Still not used to this software. So we've got 4 terms here, and we want to see if we can combine these. Now, right away, I see the last 2 terms are like terms. I will be able to right away combine those 2. But the way this is written in the first 2 terms, I can't combine those yet, but I might be able to simplify them, and in the end, maybe they will combine with this last one. So I have 2 times the cube root of negative 24 minus 2 times the cube root of 81. And like I say, these two combine to minus 4 times the cube root of 5. We've seen before that if you have a negative symbol with an odd index, that you can factor out, you can pull out that negative sign. So that's going to make that a negative 2. And now I'm just going to come over here and work with 24 and see if I can find a group of 3, because this is a cube root, not a square root. So I've got a 6 times 4, and I can write 6 is 3 times 2. I can write 4 as 2 times 2. And here I have a group of 3 right there. So I know that the cube root of 24 is the same thing as the cube root of 2 raised to the third power times the cube root of 3 to the first power, because there's just a single factor of 3 right there. Well, when you have one group that for this index, that factor, that base right there of 2, it comes out. Or that you can look at it and say 3 divided by 3, the exponent divided by the index is 1. So I know that this cube root of 24 is equivalent, it's the same thing as 2 times the cube root of 3. So, and remember, I've already taken care of that negative sign. So now I'm replacing this with 2 times the cube root of 3. I want to try to deal with this cube root of 81. Let's break down 81 and see what we get. It's awful tempting. Most of the time, our previous experience has always been with square roots. And it's true that the square root of 81 is 9 because we have 2 factors of 9. But remember, this isn't asking us for a square root. It's wanting a cube root. So this breaks down to 4 factors here. Well, we're looking for groups of 3. So we've got this group here. So the cube root of 81 breaks down to the cube root of 27 times 3 times the cube root of 3. The 3 plus 1 is 4 factors. But like I say, you have one group of 3. You have an exponent 1 here. One group of 3 times the cube root of 3. So that's what this, that's what this factor there is. It is 3 times the cube root of 3. And we already, that for that last term there, we already broke it, we already combined it. We can see that there's just a single factor of 5, not a group of 3 of them. So we have this. Well, let's come in and multiply these coefficients together so that we can add all these up. A negative 2 times a positive 2 is a negative 4. And notice we have a cube root of 3. And a negative 2 times a positive 3 is a negative, we're subtracting 6. And again, we have a cube root of 3. Now over here, we have the oddball. It's not a cube root of 3. We've got a 5. So it's these two that are like terms, and this one is unlike those two. Negative 4 minus 6 is a negative 10. And I can't go any further. I've simplified this as much as we can. And we simplified it quite a bit. Look, originally it had 4 terms. And of the 4 terms, 2 of the radicals needed to be simplified. And when we did that, we noticed that there were some like terms within this that we combined them, and now we've gone as far as we can go. So that's our final answer for number 9. Unless I made some type of a silly error, and normally you students are pretty good about telling me when I do make some kind of crazy error. So this problem is similar to the last problem, similar that it has 4 terms. And now, not all of the indexes are the same though. We've got an index of 3 and an index of 3. And look, that's a cube root of 6, and that's a cube root of 6. So right away, I notice that this term and this term are like terms, and 6 just breaks down to 2 times 3. I don't have a group of 3 within the cube root of 6. So I can immediately combine these two terms to a negative 2 times the cube root of 6. Now, these other ones are fourth roots, and right now the numbers are different, but I suspect we'll be able to simplify them. So let's just write what they are. Minus 2 times the fourth root of 96 plus 2 times the fourth root of 405. Well, I keep writing bigger and bigger, don't I? So let's start with the 96 and try and break it down. I can see it's divisible by 3, or I can play with the calculator. And 3 times 32 is 96. And we've looked at 32 enough now that you probably can say, well, that's 2 to the 5th power. If not, then we'll just keep going. And there's our 5 factors of 2. So, but remember, we're looking for groups of 4. So we're looking to break down the fourth root of 96 as the fourth root. Well, we have enough of these 2's. In fact, we had more than enough. We had a single 2 left over because we have 5 factors of 2 right here. We're looking for, maybe I shouldn't have circled 5 of them. We're looking for groups. We're looking for groups of 4, and there we found one. And these other stragglers, this 2 and this 3, are not going to simplify. So having one group of 4, we can say 2 to the first. And since we couldn't simplify these, we can combine them underneath a single radical. That 2 times 3 is 6. So we can return to this and we can say, well, that first term, I can't do anything more with it. And this middle term, this second term here, I can replace. Be careful that we've got this 2 here. Don't confuse this first 2 with this second 2. Uh, 2 times the fourth root of 6. Well, now I'd like to break down the 405 and see what's going on there. So it ends in 5, so it's divisible by 5. So play with the calculator, and I think that you'll see that 5 times 81 is 405. And 81 is 9 times 9. 9 is 3 times 3. We're looking for groups of 4, and we found one. So the fourth root of 405 can be simplified, and we can break it down to the fourth root of 3 raised the fourth root of 81 times the fourth root of 5. And the fourth root of 81 is just a very ugly way to write the number 3. You have one group of 4 factors, and the index was 4. That's why we grouped them in size of 4. And since we had just a single factor of 5, we can't simplify that. So we can come over here and say that this fourth root of 405 can be rewritten as 3 times the fourth root of 5. So we have this cube root of 6, and it's unlike the others. And here we've got minus 4, and here 2 and 3 we've got 6. And since these are both, oh, wait a minute, 4th root of 6, 4th root of 5, huh, that's as far as we can go. Don't, be careful. Just because this radicand right there is 6 and this radicand is 6, these are unlike terms because their indexes are different. So all 3 of these terms are unlike. I can't combine them any further. So there's our final answer, and that was the final problem, I believe. So hey, I hope that helps. Ask me any questions as needed, and I'll talk to you later. Bye.